Alright, draft physics video. Trying another camera because the other one seemed to have a little bit of noise in it for no good reason. Same style camera, flip, old flip. Anyway, out of business flip. So, I was going to make a video on momentum, coincidentally. But this John Adams guy, very detailed critique of particle gravity, and so I think I'll go through his points. And it'll end up being similar to a momentum video, except not exactly. Because the biggest critique against particle gravity is some sort of drag issue, which in the context of this conversation, let's point out, I'll point out, that if thought about correctly in terms of understanding the weight of particles and their function, you can account for the force that creates magnetism, that conveys it, the force carrier, which regular physics has always left quite a big question mark, virtual photon kind of a thing. They have no idea. It also explains the photon, and then it explains the nuclear forces that are holding electrons and protons together. So if done correct, particle theory is push particle. Let's call it that, maybe PP. Yes, PP takes care of everything. It unifies physics. So in that context, let's understand that this one problem, okay, might not be a problem after all. The problem might be in the amount of imagination people are applying to the understanding, which is sort of ironic. This John Adams guy is a journalist of some kind, and he has some Feynman videos in his favorite list. And in one of those videos, Feynman is talking about how you need a lot of imagination to be a physicist. And ironically, it was Feynman who's cited. This is sort of untimely. Yeah, we can let it pass. Alright, it was Feynman who's cited as somebody who has created some sort of debunk of particle gravity with this analysis that I say was fairly superficial in terms of comparing it to raindrops, when a physicist should know that the underlying physics is probably a little more complicated than raindrops, big giant molecules of water. So anyway, so I guess with that context, let's roll into these critiques. And I'm probably going to jump on a lot of language because it's sort of important to the assumptions made by the people who can't see it. And the argument is because you have these axioms that make it impossible for you to see. The gravity particles are thought to be as classical particles with classical interactions. There's no such thing in the first place as a classical particle. So even that word, electrons are very different than photons, certainly if you think photons are particles. And you certainly could say that all the other quarks and neutrinos and all that kind of stuff each one is called a different thing because it has very different properties. So the very idea of calling something a classical particle with classical interactions when there is no such thing as some sort of standard particle with standard interactions, right there is your prejudice is sort of showing. This notion is inconsistent with current understanding of particle physics. Again, it was your straw man. So first you say that they think everything's the same, and because you're not recognizing any distinctions with the size of the ultramundane particles would have, in terms of the fact that they're much smaller than all the other classical particles. So again, it's just, you're a straw man, and then you debunk it. Sorry, no sale on that. There is no particle which could have all the characteristics required. So here he's saying, and the characteristic is the ability to push. Okay, so just to understand his sentence, there is no particle which could have all the characteristics required by PG, particle gravity, without violating one or more physical laws. So all of the characteristics are it has to push things and it can't create drag. So those are all of the characteristics it has to have. There's no other characteristic. That's it. So I'm just saying, obviously the rhetoric is intended to imply, and the implication is, whoops, swing and a miss. Okay, so number one, just wipe that off as just being silly rhetoric. There's no argument there. Number two, the particle flux. So again, now we're talking about the field of particles. Filling all space must be perfectly isotropic. Well, that's of course the argument, is that the universe was originally balanced, and there's pieces in it now that are creating unbalance. It exploded or something. Something happened and it got unbalanced. But yes, it was balanced in the beginning. It started off balanced. That's the argument. The argument is that the universe might just be error code. It's not good function, it's bad function. So again, your assumptions, these are your axioms going into the argument that have no foundation. You've just assumed that somehow the universe is evidence of unisotropic, which of course it is. But it is because we can't see the whole thing. We can't see all the left and rights. So, but yeah, it's already conceded by your own theory that something disrupted the peace. That's obvious. Okay, no known form of radiation or particle flux has these characteristics to the degree required by the theory. So again, what characteristic? The characteristic is that it's perfectly conservative. Okay, and we exist in a universe where something happened and the equal and opposite reaction is happening. The universe is reacting to the action. So again, what about the theory has to explain what? So number two, completely empty argument. I mean, there's no argument there but your own straw man. You know, gee, this is easier than I thought it would be. I thought they were better than this. Well, they must get better because I'm making the video, so I must have thought there was something here to argue. Alright, so now we're on the neutrino, modern proponents of PG. Well, I don't know who modern proponents of PG are, but I'm arguing my theory of particle gravity, and mine includes polarization. Mine explains magnetism, the photon, and the nuclear forces. Mine explains charge. So I guess I'm just saying, if you're going to argue some other proponent, I'm not just doing this proponent thing. So if that's the game we can all play, then I can just find any string theorist or any wacky theorist, okay, that has in the envelope of believing in warped space-time and believing how many things Huygens and Heisenberg. So I find somebody who believes in those three things, and no matter what they say, you have to account for it. Is that how it works? I'm defending my theory of particle gravity, not somebody else's theory. Often posit, so here we go, the neutrino as the mitigating particle in the theory. That's their problem. I don't even accept the neutrino as having a defined set of properties because in many of the classical interpretations, in your interpretations, your group's interpretations, it's an antiparticle. Therefore, it's not really a particle, it's an empty space in a field of fermions or something. Fermions. This has been conclusively disproved, so again, straw man all over the place, by Richard Feynman, Lectures on Gravitation, 1995. So again, I'm not making the argument that particle gravity is created by neutrinos. You couldn't see particle gravity. I mean, there's no way to. It's like seeing photons. You can't do it. There's no way to interact with them but except completely. So you would never be able to define them as even a neutrino. Alright, anyway. So number 4. Transparency of matter. With increased mass, the change in gravitational shielding becomes mathematically less than the sum of the shieldings of the two bodies. Alright, with increasing mass, the change in gravitational shielding. So again, you're assuming that this particle gravity is affecting the surface of the planet Earth. The argument is the particles go right through the Earth, okay, and they interact by a proportion with every single atomic atom and every single nuclear bit. So this again is a fake argument, because even the hundreds of year old Lesage gravity understands that essentially that it's a nuclear force, that it's going through. It doesn't bounce off the Earth. It doesn't push the outside of the Earth. So I'd almost say that's sort of a gratuitous cheat to put that argument in there, because the most classic particle theory doesn't even argue that it bounces off any surfaces of the Earth. It bounces off the nuclear bits. Okay, so that's just, that one is a real bogus argument. To overcome this one has to place an extremely high lower bound on the flux density of these particles. Well, clearly the argument is that they're insanely dense. That light is a tiny proportion of them. It's a tiny, tiny, tiny fraction of them that are in the form of a photon, and a small fraction in the form of a magneton. The most of them are in the form of a graviton, and it's a huge density. Yes, very small, very dense. This is inconsistent with experiments conducted to detect such flux emergencies. Energies. Oh, they're energies. So citation. That's all I can say. You don't have any such experiments. So wrong. No way. Sorry. No sale. We don't have a photograph of a photon, and you're saying you have experiments demonstrating there's no transparent photons. Yeah, I don't think so. I don't think you have a chance in heck. All right, it's 5. Finally, drag. I mean, that should have been number 1. I mean, it is the only, in any sense, you have to really think. You have to use your imagination to really understand when you think about kinetics, and you think about a frictionless environment, and you think about particles moving the speed of light. Yes, you can start to figure it out, but it takes some, you have to do a little thinking to get it. All right, drag. Any mechanical model of particle gravity necessarily creates a drag force. So again, you're saying it necessarily does. And you're saying any. And you don't have evidence of any. Have you studied every single possible mechanical model? I'm arguing that you haven't come close to doing that. You're just saying what we have considered. So if, say the sentence fairly, say any model we have considered, say it that way, creates drag force, or else there would be no interaction between the particles and the massive body. So again, my argument is that it's more subtle and complicated than that, in the sense that this force is polarized. It does create the magnetic forces, and you have to understand what that means in the sense of the whole right turn business. So I have explained before that a kinetic interaction, a pure kinetic interaction, is an invisible interaction in some respects. Two things collide. You could argue they bounce off of each other, or you could argue they go right through each other. And both arguments would be, you'd be incapable, if it took no time, if it consumes no time, and there's no way to tell the difference from the outcome. The outcome is going to be exactly the same. Now the difference would be if one is black and one is red, well then you're going to know what they did, whether they reflected or whether they passed through each other. And then the complex part gets to be the perpendicular reaction, where that becomes even more obviously important in the sense that there's a huge difference between the outcome being the black going this way and the outcome being the black going this way. 90-degree difference, big difference. Okay. In order to reduce the amount of drag to levels consistent with observation, the speed at which these particles move must be in the region of 10 to the 17 meters per second. Well, I don't know what the speed of light is, but the argument is they're moving exactly the speed of light, which is many times the magnitude higher than the speed of light. Fine, I'm saying there's no obligation for that to be the truth, in my opinion, because it's kinetic, the interactions, and because of this right turn rule, okay, the identifier moves to the right, which means a 90-degree turn. When you have 90-degree turns, then you have circles possible. And once you have circles possible, you have uneven mass on the two sides of the circle possible, which means the side where the force is going this way has more mass in it, so it's moving more mass. And the side going this way has no mass between it, and so no mass moves this way. And in that respect, you can have something that will circle, spiral, its way in a direction. The matter will move, and it will move against any incoming force. There's so many ways to try to illustrate this, but let me just do a quick one. Just a way to theoretically understand it. First off, just understand that everything's moving the speed of light, all the little bits. So in a sense, the argument is sort of like there's two places to be in the universe, okay? Place A and place B. And if you were to move from place A to place B in a field of energy, you kind of have to understand that when you jump to here, you kind of have to jump over the energy going this way. And the argument is you're jumping into the energy going this way. So in the time it takes you to jump, you will hit more of this than you'll hit of this. But the counter to that argument is once you get here, the equal but opposite reaction will catch up with you, and you're going to end up getting hit by more of this than this. So in that sense, we know it can't be that way. That's not how it's working, because that's not what happens. Things don't get to a destination and then get pushed a little foot forward by the force they jumped over, so to speak. That they exceeded they somehow avoided this force and they ran into too much of this force. But you can sort of understand that if everything's moving the speed of light, okay, and all you're doing really is switching from particle going this way to a particle going this way, from a particle going this way to a particle going this way, and that's really how you're moving. It's just that you're switching more to these particles than you are the ones going some other direction. But anyway, let's just say you understand that when you go someplace, you're not really going to avoid anything, because it's the same pressure everywhere. So jumping over it in time doesn't really going to make any difference. All these things are going to hit you. They were going to hit you here, they were just going to do it sooner. So when you jumped here, you just delayed when these were going to hit you. And by jumping here, all these things were going to hit you when you're sitting here. You just jumped into them quicker, so you just changed in how much time you encountered them. And so you sort of have to understand that in that model there's complete conservation, and theoretically you're not committing a superpower by having a compensation for the fact that all you're really doing is taking time. Time is the only thing making you seem to hit more force, because the fact is you're going to encounter just as much force in the one location as you did in the other location. All the same force will get to you eventually. Right. Another way to look at it is say if the matter is made of components that have an identity, and they're always changing, but at any one time they have an identity. And say something's got the identity of moving. That means it's carrying more force going this way, and it has less force going this way or the sideways or these other directions. A way to think about it is that it's just a collection of pattern. So when it hits something, say an arrow comes straight at it, let's make it a red one just for the sake of clarifying the argument, and you have what might be called a reflection, so this would bounce off and this would end up being an extra arrow going the wrong way. Well, the trick is if this pattern decides to capture this arrow and call this itself, so it just says, no, I'm going to keep that arrow as me, then it can just get rid of this arrow and say, I don't want this one anymore, so that's not me. So it lets go of the arrow going the wrong way. It keeps the arrow going the right way. And it could do exactly the opposite. So in a way you can understand that it wouldn't matter how much stuff came at it if it just grabbed the stuff and called it me. Grabbed each reflection and just called that part of me. So if the thing can grab that and get rid of the stuff in its end going the wrong way, you could see it could just plow right through an oncoming field as if it didn't exist. The more complex truth, I think, has to do with the fact that nucleuses of atoms are probably the thing that are the most gravitational, in the sense that they have a mechanism for overcoming gravity, in the sense that they have that uneven circle. So because of the arrangement of charges, what they're doing is this cycling force in a circle. And the key is they have no matter bits in this part of the circle and a bunch of matter bits, like electrons, in this part of the circle. So the side of the circle that has the most matter bits in it is the side going the direction of the velocity. So they're all orientated almost like a magnetic domain. They're being orientated to this side of the velocity. So they're just collecting on the side that has the motion, the direction is in. So more force comes in and it goes into the side that has the directionality already, so to speak. And that would explain sort of also why it takes, obviously it takes an extra amount of force to be able to add velocity. Once you have established a velocity, you need stuff going as fast as you, plus you need a force moving as fast as you, plus, to gain any more momentum. But so obviously there's models. You know, these models aren't all models that you've considered. So again, the question isn't to say something, you know, bold, all the mechanical models fail. I think is an irresponsibly aggressive statement, because you don't have evidence that they all fail. Alright, in order to reduce the amount of drag to levels consistent with which is many times the magnitude. Again, so the fact that the forces all move the same speed is more evidence of the fact that it's all one thing. So it's all one bent space, field, ethery thing, or it's all one particle. And my argument is the particle gives you the option of polarization, and it will explain all of the other forces. But yes, it's a particle force theory. All the forces are these particles. Okay. 6. Heat energy. If the particles of particle gravity move at a supernuminal speed, which again, I didn't even see that argued in Lesage gravity, but whatever, which is in violation of the basic physical principles. Again, this is straw man in the sense, okay, I understand you don't want to argue my theory, but there is a website. I do have these arguments on it, linked below, and it has the whole kinetic thing here, and the argument about the polarization and its effects on the electrons and the protons, and it needs to be fixed on magnetism, but its magnetism is correct. It's just that I have a third particle in there that's not necessary. I have a neutral particle. But this diagram is perfectly correct. So anyway, so yeah, I mean, I don't. It's okay for you to say you know what all particle theories look like, just like we all know that current physics, they all have the same exact theory, which they don't. So, you know, it's kind of unfair to argue somebody else's theory at me. That's all I guess I would say. But whatever, it's an unfair world. Okay, so let's see if there's a heat energy. The particles with PG really move at supernumerary, so okay, they would impart a heat energy into the massive bodies significantly high to instantly incinerate any forms of normal matter. So of course this theory doesn't contain any heat whatsoever. Everything's a kinetic entire reaction. There's no bits, there's no runoff, and again there's no drag. So you're just making, the heat argument is just another drag argument, and there is none. Aberration. In a mechanical model of gravity, so here we go, again, another version of particle gravity in any mechanical. So again, the word any is used. Model of gravity. The gravitational force can only act with finite speed, creating an aberration effect. Such effect has not been observed. So this argument is, again, almost denying that particle gravity would have to have in it the inverse square law. And the inverse square law is basically the no aberration law. So let me explain. Again, I've done this before, but you have to understand how gravity is induced. For every step the Earth takes towards the Sun, a mass equal to the mass of the Earth from the Sun moved towards the Earth. So a piece of the Sun, atoms of the Sun equal to the mass of the Earth actually moved towards the Earth. And the Sun's giant, so obviously that movement of part of its mass in the direction of the Earth is going to get eaten up by the swirls and all the other pulls and pushes that are going on in the Sun. The Sun is rotating, it's swirling, it's doing all kinds of things. So that momentum will be eaten up into that angular velocity. So, but the real point, so I'm just doing that as a preface so you understand the theory is basically saying that gravity is induced. Something has to move towards something to make it more gravitational. The shadow isn't created till the thing absorbs something, and it only does that if something else absorbed it first. So they have to absorb before each other moves. So it's a induced. One pushes, the other one pushes back a little harder, that one pushes back a little harder, this one pushes back a little harder. That's how gravity happens. That's how you increase your gravity. Well, that's how your gravity moves things. But the real key point to make about aberration, so aberration would be this idea that because it takes time for the gravity to go from here and then go back again, the position of these things will not be correct. And so the gravity will miss because the response will come out and this will be gone and the gravity will miss and there'll be no effect of the gravity. But the point I've made before to you people is that what counts as movement, say this was the Earth and this was the Sun, what counts as movement towards the Earth is when any atom in the Sun moves in any of these 180 degrees. Anything that has a component in this direction will count as a shadow towards the Earth. And that's what creates the inverse square law. Because if you make that go the full 180 degrees this way, 180 degrees this way, this full circumference, that'll come out to the R squared rule. So basically the lines of gravity force, so it's induced this way, it comes back out in all of these vectors. And the same is true for the Earth. So when the Earth moves, it moves in all of these vectors. And because it has a previous vector going in terms of its velocity, it just combines the average. And that ends up being some kind of curve. All of these would average out on either side. Obviously, they'd be equal. So the two sides would all equal out. And so the net effect will be a force this way. But the truth is that force is made of vectors in all directions. In all directions on this plane of the dimension. So obviously there's no problem with aberration because the force isn't line of sight. It isn't straight line seeing something and seeing it reflect off. It hits and I can see it in any direction sort of thing. So it's not an issue. You can't escape. So gravity's always losing gravity to places where there's no matter. It's not the communication of gravity, the point is, the communication of gravity is not person to person. The communication of gravity is person to universe. That's why there's an R squared. That's why the force diminishes. Yeah, okay, I did that well enough. Alright, so he says no such effect has been observed. Like I said, that's only if you made the wrong assumption that gravity is line of sight back and forth, and that it doesn't do planar radiation, R² radiation. Okay, sources of gravity. This is number 8. As we know today, it's another tricky beginning, and as is experimentally well verified, another line from I Say So, essentially, right? Because we know what they claim to be experimentally well verified is not necessarily experimentally well verified. So that term is very dangerous, coming from anybody who's, got any real intellectual integrity. All forms of energy are a source of gravitational field. So again, all source of energy. I'd say that's nonsense. Magnetic fields do not create gravitational fields. I say photons do not create gravitational fields. You can pile a million photons, a laser beam with a zillion photons. It will create no gravity. Forces do not create gravity. Forces are the mechanism that manifests gravity, and they do it through being filtered by electrons and protons. But so that's just nonsense on its face. Sorry. All forms of energy are a source of a gravitational field. I don't see where you have any evidence for that. Not just mass. Well, I'm sorry. Yes, no, you have to have mass. Mass is the definition of being affected by gravity. You don't have mass if gravity isn't affecting you. Fact. This is not explainable by PG. Well, I'm sorry. What PG can explain is that physics you can't. Source. Show me a force creating gravity. Actually making a blockage of the gravity and creating an attractive force. Show me a force creating an attractive force. No chance. Time dilation. PG has no consistent mechanism to explain the well-verified phenomenon of time dilation. So again, he says well-verified. It's not really, and not by its name. Time dilation, changing time. No. By that name, no. You don't have any evidence. The only evidence you have is metabolism retardation. You could use that term for atomic particles. Atomic retardation, you could even say. The fact that velocity essentially requires multitasking, which means you will not be able to do things as fast, no matter what they are, because the atom has been expanded, essentially. So when you're moving in a direction, that means you've collected extra force in a direction, and that force has to be held somewhere. So what happens is your atoms expand, the orbits expand, something has to expand to accommodate that force. And in that expansion, and it's still going the same speed because everything has to go the speed of light. So if I have a thing circling and it's going the speed of light in this little circle, it's going really fast. It hits the 12 o'clock really often. And as I make the circle bigger, it hits 12 o'clock less often. And that's essentially atomic decay. Anything that will decay slower if you have force inside of the atomic vessel. I think that's a logical, well thought out, simple debunk of that debunk. I mean, this declaration that there's no consistent mechanism to explain. I'm just saying that doesn't take much imagination to consider that there could be lots of consistent mechanical explanations. And you've said, I declare them all debunked. And you've debunked, in my opinion, probably not even one. You've just declared it. Alright, deflection of light. PG cannot explain deflection of light rays while at the same time avoiding aforementioned problems with drag. Deflection of light. Forces do not interact with forces. Magnetism doesn't affect gravity, and none of them affect photons. Again, the only force we have evidence of affecting a force is light being bent by gravity, and I would argue that evidence is incredibly weak. So I just say that's not an issue. You can't diffract gravity. You can't. It doesn't It interacts kinetically and completely. It moves something or it doesn't move something, period. It's absorbed by something, moves it, or it doesn't. That's it. There's no other, it doesn't have any other interactions in the universe. It either hits something completely, in terms of its momentum is absorbed for a period of time, its identity is changed, however you want to describe it. It reacts 100% in the direction of its movement, and that's it. Or it doesn't. It hits or it misses, period. Alright, thermodynamics. So this sounds, again, like another drag argument. The flux of particles in PG, so again, calling it a flux, that's your use of your terminology for things that you have not even correctly defined, which are things like magnetic and electric flux, which is the field you can't account for, the force that you don't have any origin for, so you have to call it made out of a virtual thing, a virtual photon of some kind, a virtual force entity, because you don't have a mechanism. At least PG has a mechanism, and especially my PG does. Yes, Lesage didn't talk about magnetism and electrons and protons and the photons. I am. The flux of particles in PG would be many orders of magnitude more energetic. Sorry, no. Than mass at rest. No. The argument is all the mass, the electrons, protons, and neutrons, let's say, and whatever little bits they're made out of, they're moved by the force. So they get hit by unbalanced force, they will go where the unbalance forces them to go. And they go there based on polarization. One being affected by the black bits, one being affected by the red bits. It's on my website. And that's it. The matter just goes where it's placed. And it can't keep momentum until it makes the circle, until it makes the square that it can imbalance, the warped square that allows it to spiral into a new direction. Alright, however, no transmission of energy is observed. Well, clearly we observe a ton of it in magnetism and all these other things, so to say no transmission of energy is observed when we watch the planet Earth moving towards the sun and off of its straight line vector bent into the sun, and we understand that it's really hurling there, and we really understand that if I'm up in the sky, we certainly understand the power of gravity as you're hurling towards the Earth. And if I took away the atmosphere, you'd really get the message, because your velocity would be insane. By the time you hit the Earth, you'll be going thousands of miles an hour. You'd really get the message then that there's energy involved. So that argument, however, no transmission of energy is observed. Clearly, the transmission of energy is obvious. When you're moving thousands of miles an hour towards the surface of the Earth, you're going to sit there and say, yeah, there's some energy going on here. Anyway, even though there must be a form of interaction with ordinary matter. Again, where would you say PG, or particle gravity, claims there's no interaction? It claims that the interaction is essentially a nuclear, little bit interaction, and it has to do with certain fundamental simple rules of interaction. In my opinion, the simple rule, in my version, the simple rule is the interactions are kinetic, and if it's a perpendicular interaction, it's a 90-degree turn in the force. In terms of the reflex, the equal but opposite reaction goes 90 degrees. This leads to a violation of the laws of thermodynamics. Well, we've already been over that, but no, it doesn't. Perpetual motion, due to, this ought to be interesting, due to shielding effects. So again, we're talking shielding effects is not a real phenomenon. There's no such thing, because the particle gravity is interacting with little tiny, perhaps geometrically square bits, okay, the little tiny ones, in a very, it's very square geometry, straight line geometry. So there is no shielding effects. The existence of PG would make it possible to construct a perpetual motion machine. There's nothing in the argument that has any possibility of that. All you can do is you can be completely, without using any energy, without consuming something, okay, you can turn right. Going straight and turning right don't require energy. That's all. But there's no perpetual motion because you don't have to use energy to go right instead of straight. It just means you can create a circle. The circle doesn't cost anything, just like it didn't cost the astronauts anything to go around the moon a couple of times and then fly back to Earth, just on the momentum it took them to get to the moon. Would you say that that's not possible? Because it is possible. It's free turning. Turning is free. It doesn't cost anything. If you're done right. You do it wrong, it's expensive. Do it right, it's free. But it's not perpetual motion again. It's just trapping a force in a box. It's storing it. That's what a battery does. That's what everything that stores energy